Hello guys, welcome back to Infinite Insight Geometry, Lesson 3.4, SSS, SAS, ASA, and AAS. These are all congruencies. Let's begin. So, for this lesson, Lesson 3.4, we will be focusing on how to prove triangles congruent. And there are four main ways to do it with any triangles. But first we have to learn two definitions. An included side is a side that lies between two angles, and an included angle is an angle that lies between two sides. So just visualize a triangle for a bit. Take two sides of that triangle. The included angle would be the angle that makes up the two sides. And an included side, take two angles. The included side is the side that connects the two angles. You'll see it better later with a more accurate diagram. So what are the ways we can prove triangles congruent? There are four main ways, like I've said before. We're going to go through each of them one by one. Side congruency. If two triangles have all three corresponding congruent side lengths, then the two triangles are congruent. So if you have a triangle with lengths 4, 5, and 8, if the other triangle has lengths 4, 5, and 8, then they are congruent. Notice how I say corresponding congruent side lengths. First, you have to correspond the sides, then you have to prove they are congruent. Then you can prove the two triangles congruent. It's the same with side angle side congruency. If two triangles have two corresponding congruent side lengths and their included angles are also congruent, then the two triangles are congruent. As you can see, you have two sides of a triangle. They are both corresponding and congruent, and their included angle of both of the triangles are also congruent, so the two triangles are congruent. You also have angle side angle congruency. You have two angles and their included side is congruent, and the two angles are congruent, so the two triangles are congruent. It's just two corresponding congruent angles and their included side. Now, angle side congruency. This is a bit weird, but bear with me. If you have two angles that are congruent to each other, you also need one non-included side that is corresponding and congruent, so that the two triangles are congruent. So if you have, say, two triangles, and then there are two angles, then their included side, if the included side were congruent, you could already do it by angle side angle congruency. But if if they're not necessarily congruent, then you also have to prove one of the other sides congruent. So you can prove it using angle side congruency. Alright. Now, there is one more thing that I want to touch up on, and that is how these are called congruencies. They are not definitions, postulates, or theorems. So what are they? Well, these congruency theorems are just called congruencies, but they are really just postulates. All of these are postulates. We just call them congruencies because it's easier to denote them in two-column proofs. Because if you say congruency, you're saying, oh, we're proving two triangles congruent. That's why we're saying it as a congruency. SSS congruency, SAS congruency, ASA congruency, and AAS congruency. They're all postulates. They're just named congruencies because we are proving two triangles congruent. So, let's take a two-column proof example, because this is a very hard lesson. So let's teach you how to do one of the congruencies, and now which congruency theorem to invoke whenever you're trying to prove two triangles congruent. Alright, look at the diagram. If point C is the midpoint of AE and BD, then prove that triangles ABC and EDC are congruent. I'll give you a moment. Pause and think. Maybe if you would like, maybe actually try and solve the two-column proof yourself. I'll give you a moment. And here is the entire two-column proof. So you have the statements and the reasons in one column and the other column. C is the midpoint of A, E, and B, D. That's already given. So, by the definition of midpoint, AC is equal to CE and BC is equal to CD. These lines are also intersecting. AE and BD are intersecting lines that intersect at C. Those are the definition of intersecting lines, and we can even see on the diagram they are intersecting lines. Angle ABC and angle EDC are vertical angles. Look at the diagram. You have two intersecting lines, and their opposite angles are the vertical angles, meaning that by the vertical angles theorem, we can prove that angles ACB and ECD are congruent by the vertical angles theorem. So we have one side that is congruent with those triangles, and we have another side that is congruent. So what can we do with this? Well, we have two sides, and then we have their included angle. Look, there are two sides, and the angle that we just proved congruent to another angle makes up the two sides. So we can use the side angle-side congruency because the angle is in between the two sides. So side angle-side congruency, meaning that we can prove that triangles ABC and EDC are both congruent. In the next lesson, we will try and prove right triangles congruent, specifically all of the congruencies listed in this video are also valid for right triangles, but there is another congruency that we will talk about, the hypotenuse-like congruency, that only right triangles have that property. And that'll be all for today's lesson. If you liked the video, please like and subscribe. I have my email down below if you have any questions, and I'll see you all next time.